It is a really great pleasure to introduce Tim Fern, G4LOH. For quite a few years, I used to beat up the RSGB Propagation Studies people for not doing too much at VHF. But in the last 2 years, it's a total turnaround because we've got Chris G4IFX doing work on 50 megahertz polarization, and they've recruited Tim. So Tim holds goodness knows how many distance records on VHF for tropospheric propagation. And he's going to be talking about combined mode propagation on 144 for Ultra DX. I'd like to learn more so I can do more of it. Tim.
Thank you very much, John. Well, good morning, everybody, and I'm delighted to see such a turnout. Yeah, combined mode propagation. Obviously, one of the reasons we love 2 meters so much is the sheer variety of propagation modes that it offers. Troppo, sporadic E, Aurora, Meteor scatter, I know just a few, and there's several other ones as well. And sometimes they're actually available at the same time. Now, this doesn't happen very often. There are, I guess it's the product of 2 fairly low probabilities. But they do happen sometimes at the same time, and when that happens, some interesting things can happen. There's certainly possible to work some extremely long distances. And that's what I've been looking at after John, as I say, John just introduced, started a project in the PSC. And what I hope to achieve today is that maybe next time there's a strong Troppo duct and it's 9:30 in the evening and you've already spoken to everybody who's on and given them 5.9++ reports and turned your power down to half a watt and they're still 5.9, then you'll think of something else to do. And you'll look on the KST chat, maybe find some remote Russian and see if you can work him on Meteor scatter maybe. So why not try and get a 2,500, 3,000 kilometer contact in the log? So on a more general thing, looking at all the possibilities of combined modes, I sort of cast the net wide with an announcement in Radcom and various forums around the world last year, and got a number of very interesting reports where people have in their careers of decades on the radio, have 1 or 2 contacts that they think occurred with combined modes on 6, 4, and 2 meters. And unsurprisingly, this was mostly combinations of Troppo with all other modes. Other people had heard auroral meteor scatter. Sometimes if you're a long way south of the meteor, a long way south of the Aurora, and you're trying to hear the beacon, you'll get a meteor scatter burst with an auroral tone on it. Not particularly exploitable as a DX mode, but these things do happen. And sporadic E and meteor scatter, we've all been listening to when the Germans have had a fantastic sporadic E opening, and we're getting pings and pops from the remote Russian stations, and that's probably a caudal link between the sporadic E cloud and a meteor. But for most of the rest of the talk today, I'm going to be looking at Troppo ducts linking with other modes, and then particularly at Troppo with meteor scatter, because this is quite a readily exploitable mode for DXs with a reasonable station. But just a brief mention first of Troppo and aircraft scatter. The first time I worked Delta 4,000 kilometers way down off the coast of Senegal, that contact was completed using aircraft scatter. The Troppo was reaching from Delta 4 up to the Galicia area, EA1 of the northwest of Spain, and an aircraft happened to fly over the Bay of Biscay at just the right time, and that completed the contact using an aircraft scatter link. And I do remember when I lived in Yorkshire working EA8 BTV at 3,100 kilometers, and then being delighted by the best distance of the day, and then very soon afterwards David worked him using an aircraft scatter link, and I was heartily added my congratulations to that, and he got the best distance of the day there. So next time, if you're just outside of a Troppo duct, it can be quite disappointing because everybody else seems to be working lots of DX. Well, you know, get Air Scout loaded, or just look at the Flight Radar 24, see where the aircraft are, make a sched, and you'll be amazed what signals you can hear. Troppo with Aurora definitely happens as well. Again, from Yorkshire, I work way beyond my normal auroral limit up into halfway up into Norway with LA8KK, and then there was a remarkable event last year when John made a number of contacts up to 1,800 kilometers, way north of his normal auroral ability, because of a very strong duct across the North Sea. Troppo with meteor scatter, and I'm going to talk mostly about Troppo with meteor scatter today, and this is some of the things that have been, some of the contacts that have been reported that because when I first started looking at this, people said it probably won't happen. You've got a lot of loss on the meteor path, you've got a lot of loss on a Troppo path. I don't think these things can link together. If you're hearing signals 2600, then it must be just a very high meteor or something. But there's enough evidence now that Troppo and meteor scatter does link, and it's quite a predictable mode when you've got a good Troppo duct to work with. So North Sea Troppo ducts work very well. I got a report from Holland where they had a good Troppo link across the Azov Sea and then the Black Sea. And then a lot of contacts have been made now. The EA8 stations have made 60, 70 contacts now, up to 3,000, up to 3,700 kilometers have been heard using the very strong duct that happens in the Atlantic off the coast of Africa. So there's some quite spectacular distances possible. And the stations are not huge. These are single Yagi stations with a decent amount of power, but they're not enormous stations, many of these stations. Some of them are, John.
The European ones are.
So I want to talk a little bit about the summer duct that happens between the Canary Islands and Portugal, because it's quite remarkably strong. And I guess if you've never experienced it, you're used to the little bit of Troppo lift that you sometimes get across the UK. I want to describe just how strong this thing is when it happens. I was in Tenerife just a couple of weeks ago talking to EA8TJ, and he says that because I'm sure you're familiar with the geography of Tenerife, there's a 15,000-foot mountain in the middle and most of the central land is 6,000 feet. They can work from one side of the island to the other, it's about 30 kilometers, by beaming up Madeira, which is 500 kilometers to the north. And they can make an easy FM contact using a reflection over 1,000-kilometer path, is how strong the duct is. And I first found this, I was trying to work Delta 4-4 again when there was particularly strong Troppo, and Joe down in the southwest tip of Portugal, he was also beaming towards Delta 4, and he could hear my signals reflected off Tenerife. We can't work directly because there's a lot of mountains in the way in northern Spain, but we can easily make contacts reflected off Tenerife. And that's, again, that distance is nearly 4,000 kilometers, 3,500 kilometers or more. So this is how strong the duct is. And my favorite contact of all was with the Azore station, CU3EQ. Again, nothing on the direct path, but by both beaming at the Canary Islands, we made an easy contact, and I was only running 70 watts, and that was an easy CW contact over 3,500 kilometers. So this phenomenon of the ducting that exists in the Atlantic, even though you don't directly couple into it from the UK, I wanted you to understand how strong it is, because you can couple signals into it using meteor scatter. So I'm going to do a one-slide Troppo recap. Typically, the refractive index of air, 1 with lots of noughts, 3. So we have this term we define N, capital N. Take off the 1, multiply by 1,000,000. So typically, the refractive index is about 300 of N units. And in a normal atmosphere with no layers of ducting in it, the N value falls by about 40 every 1,000 meters. So 40 per kilometers. And this is what gives us the normal over-the-horizon slight flattening of the Earth from a radio sense that you can normally work a bit further. Now, with the Earth as curved as it is, if the N value increases to 157 per kilometer, then the refraction curve will match the curvature of the Earth. so you get a lift, you get some Troppo enhancement. In the Atlantic, the N values I've calculated from the radiosonde data can exceed 1,000. Very, very high values of N change. And here's a typical radiosonde data. You can look at this data. It's published every day on the University of Wyoming website. There are radiosondes. This is the Tenerife one, but there are radiosondes all over Europe. You can see the multiple ducts here at various layers up to, I think, 15,000 meters there. But this extreme duct at the bottom here is where you get the very, very high N values. I believe that's a subsidence duct, is it? Yeah, Jim. And there is a picture of a very similar thing just coming into land into Tenerife. You get these incredible sharp layers in the atmosphere. So it's interesting, if we're talking about coupling between a meteor signal, you've gone up to 85 kilometers up into the ionosphere, reflected off the trail, and then how do you couple that signal into the duct, and what happens at that duct? So using data from the previous radiosonde data, the formula here, which came from Mike Willis's tutorial, although he sent me an updated formula, I didn't use it. It didn't change the numbers all that much. You can put in two values of pressure and temperature taken from the graph. You can calculate what the DN value is, and in the case of the previous radiosonde, it came out about 1400. Depends exactly what data you take off the graph. And then using the known N value, you can calculate the critical angle, which is the maximum angle that the duct will capture the signal. And there's a formula at the bottom. And with these high N values of 1400, the capture angle is about 3 degrees, which is quite a high value. 3 degrees, incidentally, is the glide slope angle for commercial airliners. So next time you're at Heathrow, you can see all the aircraft stacked up coming into land. That is exactly a 3-degree angle, if you want to visualize that. And if you were to extrapolate that 800 kilometers beyond, up to 85 kilometers and then back down, it gives you a meteor scatter range of about 1,600 kilometers. There's a graph here, doesn't show up particularly well on this, but for a 3-degree takeoff angle, you're looking at a meteor scatter range of 1,600 kilometers. Now, often the angle that the duct will capture is less than 3 degrees, in which case you need the meteor scatter range to be greater. And obviously, if the duct is not terribly strong, you want the signals to be arriving pretty much tangentially as they arrive back at the Earth, which is a meteor scatter range of about 2,100 kilometers, depending on the height of the meteor burn. So a quick bit about meteor scatter. I know John did a presentation which I watched a couple of years ago at this event. Meteor scatter needs very precise geometry. Imagine the mirror on the hillside signaling with the sun. You get this glint of a signal. You need a perfect geometry to hear a signal reflected off the meteor trail. And it actually requires the two stations to be located at the focal points of a prolate spheroid, which is like half a rugby ball shape. And it's that need for this precise geometry which causes the shape of the bursts that we're all familiar with. So, or anybody who's operated meteor scatter, you will know how you get plips and plops and pings and bursts, but there's a sort of shape to them which you get quite familiar with depending on which band you're on. So we're going to look a little bit about this interface here between the meteor trail and the Troppo duct. Higher values of N change will allow the capture of shorter range meteor scatter paths, and weaker ducts will actually still capture longer range meteor scatter reflections. But there's more to this than considering the interface between the two modes as the second focal point of that prolate spheroid. I'm going to say that again. Normally, in this, you imagine this rugby ball shape in space. You've got a meteor trail up there. You've got one signal here, perfect geometry, other station down here. You could consider Meteor scatter with Troppo, that the interface between the duct and the returning signal is just at that point. But from what we've heard with our experiments, we think there's a bit more to it than that. What people are reporting, having made Meteor scatter contacts, or Troppo with Meteor scatter contacts, all the reports, and this may be coincidental, but it's just an observed fact of all the reports we've had, they all involve a mode interface over the sea. This could just be because you get these strong Troppo ducts over the sea, or it could be something to do with the way the signal gets into the duct. The bursts are quite infrequent. Don't expect to complete a sked in 10 or 15 minutes as you might normally do, but they can be surprisingly strong. And the other thing that's been noticed is that the burst profile of what you hear is the attack and decay times of the burst can be different. Not all of them, but sometimes you get these bursts which are very, very slow. We call them lazy bursts because they sort of haul themselves out the noise and they hang around there and then they'll slowly fade away. And you think, well, that was very odd. I don't normally hear bursts like that. And I've got an example now, some recordings made by John just a couple of months ago. Let's hope this plays all right. Not playing. Right. Do you know where the volume?
Is it volume on PC?
Yeah. Where is that?
Down at the bottom. Down at the bottom on, look, you've got the speaker turned off.
Yeah. Oh, okay. That would do it.
Rewind. No, you need to
Yeah, I'm going to do that. Let's try it. Okay, we'll try that again. Now the burst starts towards the end of this period. This is FSK 441, so you've got a 30-second period, and there's a 30-second receive period, transmit period. Okay, so that's towards the end of the signal. You see that it just slowly hauls itself up out of the noise, and then there's a 30-second transmit period, and then the following 30 seconds, so this is nearly a minute later now, this happened. So this burst was still going on. And this is a signal sent from EA8TX on Tenerife, 3,000 kilometers away. And this was on the 18th of July, so quite well beyond the peak of the Perseids. Sorry, before the Perseids, well beyond, yeah. Well beyond, so outside of a shower, and you get this incredible long, slow burst. And that's quite characteristic of what we hear with Troppo with Meteor scatter. Not all bursts are like that, you get shorter ones. You don't often hear much Doppler shift, but you do get these incredibly long bursts. The first time I ever heard this, it was one of those nights I was in Yorkshire. There was a fantastic Troppo across the North Sea. It was 9:30 in the evening. I'd already worked every station that was on the band with huge signal reports. So I went on to KST, found a Russian station way beyond Moscow to try a Meteor scatter sked with. And within 5 minutes, I got a full 20-second burst from him, was S9 plus, and I thought it was just somebody messing around from Holland or somewhere. So there is this phenomenon. Right, hope you enjoy my graphics here. I couldn't be bothered to learn a new drawing package, so I just draw it and photograph it. So what we've been talking about so far is a simple model, transmit, perfect matching geometry off the Meteor trail, duct angle capturing at 3 degrees. And that might be what's happening. And in many cases, that is what's happening. However, in a real world, the ducting is not completely smooth on its surfaces. This is an acoustic chirp sounding made by Andrew Martin in Australia. He sent me a picture, and this is the ripples on the top of a duct caused by the wind shear of the layers of air moving across. You get these ripples in the top of the duct, and these ripples allow signals to be captured into a duct from its top surface, provided the angle of incidence is very, very low. And given that the signal, you're not normally, when you're in a Troppo duct, both signals are below or within the duct, or transmitter and receiver are both below or within. But of course, with Troppo and Meteor scatter, one of the signals is arriving from above. And what could be happening and what could be causing these lazy bursts is that you have a meteor trail, and that the need for perfect geometry can be satisfied over quite a range, tens or hundreds of kilometers along the trail, and that the signals can then arrive back virtually tangentially onto the top of the duct. And I believe that this is what's causing these lazy bursts and this change in the attack and decay profile that we hear on Troppo with Meteor scatter. So bearing in mind that could be happening, and this is also applicable to Troppo with Aurora or Troppo with sporadic E, that this coupling method is possible. Right. So, and I think I've just said what's on this slide. The Meteor scatter signal couples into the duct from above in real-world ducts, such that the second focal point of that prolate spheroid we're talking about actually becomes a line, and that there is a line along the top of the duct in which the Meteor scatter geometry is satisfied, and that's causing the extended bursts. So, summary. Oh, I've gone too fast. Yes. Troppo does reliably link into aircraft scatter, Meteor scatter, and Aurora, sporadic E. There are some other modes available, but they're a bit too infrequent to be of much use. But Troppo with Meteor scatter is a widely exploitable DX mode. And even though here in the UK we're well away from that super duct that you get in the Atlantic, once you know it's there, you have the confidence to try the skeds and exploit it. Longer distance Meteor scatter links will link into less intense ducts. So if you, armed with this knowledge, you can design your skeds and make some super long distance contacts. So an intriguing possibility is this going to finally enable us to crack the transatlantic path? Now, this is obviously been a holy grail for many years as to whether this is possible. Having looked at the distances that have been worked, and here we are talking about 3,000, 4,000 kilometers on 2 meters, 3,000 kilometers across to VO1 doesn't look that hard. It is hard because the Troppo ducting this far north in the Atlantic is much weaker. But it does happen. It does happen for a few hours a year, maybe sometimes a day a year. You get a Troppo duct showing up on Hepburn, extending 800 to 1,000 kilometers out in this direction. And with a Meteor scatter burst, and because you need it to arrive back at the Earth tangentially, then that you want to use about 2,000, 2,100 kilometers of Meteor scatter range to make this path. So you need about 900 to 1,000 kilometers of Troppo range from the east coast of Ireland, or 1,200 kilometers from the coast of Cornwall, funnily enough. So one of the other reasons this doesn't happen or hasn't been tried very much is because there aren't very many stations in VO1. But there is now a beacon. VO1FN is a receive beacon with 2 5LEs, and you can log onto it remotely. It's in a fantastically quiet VHF location right looking out over the sea, so it also benefits from surface gain off the sea when you're making a meteor scatter attempt. It's got a good masthead preamplifier, and I have actually got signals to it by reflecting them passively off of the ISS. There's a video on YouTube of that, and I did that to calibrate the frequency accuracy, because this thing's just got a little dongle plugged into a PC. So I wasn't too sure on what the frequency accuracy of that would be, and it turns out it's actually only 100 hertz off. It's about 100 hertz high, and that was calibrated by reflecting a signal off the ISS over a 3,400 kilometer path. So there's this resource. It's available 24/7, and I think if there were a suitable high power station available on the west coast of Ireland in particular, at the right time of the year when the Troppo duct existed, you'll be able to hear your signal reflected using Troppo with meteor scatter. Before I finish, there's a plea from EA8TX and TJ, the guy to my right and left there. These guys, they live on a remote island in the Atlantic Ocean. They operate VHF. You know, that takes some dedication. They love working this mode. They would love to work with more stations all across Europe, but they say, please be ready to take 2 or 3 hours. What annoys them mostly is people come along, expect it to be completed in half an hour, and that's just wasted half an hour of their time. These skeds do take 2 hours, sometimes 3 hours, but they will stick it. If you're prepared to stick it, they will stick it and make a contact, and you get a 3,000 kilometer contact in your log. They've both completed contacts with S50C 3400 and been heard at YU1EV as well. So combined mode contacts are rare. Let's try and make them less so with knowledge and understanding, and making skeds and having the confidence that knowing that duct is out there, you can couple into it and you can make a contact. If you're just outside of the duct, because it can be frustrating if you're just outside the duct, you hear all your mates 100 kilometers away working super loud signals over in Europe. You know, get on Air Scout or get on, try and make a meteor scatter contact. Believe that it can be done, and try and get a 3,000 kilometer contact in your log that you'll always remember. Thank you very much.
Well, thank you very much, Tim. I have 1 or 2 comments at the end, but let's take questions first. If you put your hand up, I'll bring the mic over. No questions? Ah, Jim.
Thanks very much, Tim. And really fascinating. And I think the idea of the transatlantic thing, is it right that was last year we had the Brendan Challenge, or was it the year before the St. Brendan?
Oh, the expedition that I heard.
Yeah.
Yeah, that was 3 years ago.
3 years ago, yeah. I think the thing is, it's about the right time of the year to pick, to try these things. And usually in the autumn, you can get the weather patterns over the Atlantic such that the length scale of a high, you're right, it doesn't normally extend the whole way across, which it probably wouldn't ever do. But you can get 2 separate ones split in the middle by a weak cold front, and if the cold front is weak enough and doesn't damage the inversion too much, there is just a sneaking chance that with a little help in the middle, you could get something to bridge that gap. So it's not the impossibility. And your Troppo paths off the coast of Africa are shoo-ins every year. It's just a timetable thing that will always happen. So quite agree. There was an example in Blackwood, South Wales, where the operators there would suddenly tap into long-range ducts down across Biscay to EA8 and the west coast of Spain and Portugal by waiting for the sea breeze to bring up that same ducting propagation up the valleys.
Yeah.
So it's a fascinating mode. So good luck with your work with that. It's excellent.
Thank you.
Questions? Ah, Mr. Wales.
Hello, it's Lynn GW8JLY here. I'm very active on MS and I'm fairly successful, although I haven't got a big station. I've listened many, many times for signals from EA8TX when he's in these extended tests with John or somebody else when he's beaming our way, and I listen and I listen and I listen, and I hear nothing. I can and have worked EA8TX and EA8TJ on Troppo quite a lot of times, although my takeoff to the southwest is absolutely rubbish, because I live on a tiny, I can't call it a hill, but it's a slope, and I'm climbing up the slope to beam southwest. But I can work EA8TX in particular on Troppo, but I cannot hear him on this mode when other people are utilizing it. Now, I realize my distance to perhaps Portugal is, I don't know, it's about 1,600 kilometers, I think. So it should be perfect for me to couple into these ducts. But for some strange reason, I've listened loads and loads of times, and I don't hear anything at all. My takeoff to TF Iceland is pretty poor, yet I can work Iceland on a Meteor scatter over a more obstructed path. So I don't know whether it's obstructions, but there must be some reason why my QTH makes it impossible to do this Meteor scatter Troppo ducting. I just wondered why.
I don't know. Do you know what the...
I can answer that one, Tim. I've plotted it, Lyndon. The answer is you're actually too close for the antenna that you've got. It's a combination of the distance and the coupling into the duct. I think you produce about 4 degrees into a duct that will go up to EA1 because you're that few hundred kilometers closer. There are stations in the south coast of England, G3WZT is one, who couple into, whose Meteor reflections couple much further south than mine. And I think it's a question of your opportunity will be with a different duct. You won't work the same duct that everybody else will. You want one that's a bit further south, not as strong, not as far north, so that you have a lower angle of entry into the duct.
Well, I think he has been heard in Scotland.
Oh, yes.
Yeah.
On a presentation that I've done, I did a locator map, and the EA8s have been heard as far as IO78, which is GM4VVX, right up in the mountains.
Single Yagi.
With a single Yagi right up in the mountains. They've been heard in OZ, and they've been heard all the way across to about 3,700 kilometers and to YU.
Okay.
More questions? Richard.
Hi, Tim. I was just wondering, we're looking at the paths there. What do you think's the chances of working South America rather than North? Bearing in mind that the Atlantic's a lot, the South Atlantic's a lot warmer. And I was just wondering whether the E8s have done any testing over to the Caribbean or something like that.
I mean, I don't know. Jim could comment on the likelihood of Troppo ducting existing down through the doldrums down to the north coast of South America. It certainly never shows up on the Hepburn maps. I do know that Joe HZE has heard for a while. Dubas had a beacon on Fernando Noronha, PY0FF put the beacon up there, and he heard that beacon with Troppo and Meteor scatter. He was getting pings from that beacon, but that's the furthest south that I've ever heard from Europe of Troppo plus Meteor scatter.
I think one of the points from that is that to make the link work, to get the quality of duct, you've got to have really warm, dry air, very dry air above the moist boundary layer near the sea. And once you get out into the mid-Atlantic, you lose that input of warm, dry air that you have further north from the Sahara. So I'm not quite sure whether the inversion strength would be as strong, because it would all be maritime air mass.
Certainly signals, Troppo signals from Delta 4 can get very strong. They've been 5.9 plus 20 in Cornwall, and in Portugal, they're 5.9 plus 20 for days upon end during the summer. But it's hard to know how much further south that goes. The beacon in Fernando Noronha was only on briefly, I think. So it was never heard by pure Troppo, even in Portugal.
my little point of disagreement with Tim is I actually think the North Atlantic will be crossed, but it'll actually be from EA1 to VO1 or VE1. And the reason for that being is where you start to get these large high pressure areas and the ducts, which are subtropical, they often drift out and they extend up to 1,500, 2,000 kilometers out into the Atlantic, that far south. And although the path to EA1 is, I think, about 3,800 kilometers, they need 2,000 kilometers of duct, but I think that's possible. The only other thing I will say is, having gone through the analysis of E's plus Troppo to start this off, is there are always good ducks in the Mediterranean.
Yeah.
And Tim to Israel is definitely one on the cards.
Thanks. Yeah, I'd like to mention when I used to write the VHF column in Practical Wireless for a record-breaking 21 years, I should hasten to add, I used to catalogue these openings, and I did something like 10 years of openings from the UK to EA8, and I seem to recall that the openings would occur between May and September every year. Between May and September, quite a number of openings. I think some of them made passers by, but if you keep a look on the cluster, you'll certainly see them. And of course, if you live like in Elston, Cornwall, there'll be 5 and 9 plus on FM. No problem at all.
They certainly are.
Us mere mortals in Herefordshire, they'll be there. But the path will go up the Irish Sea. So if you're in the west coast of Wales, and even up as far as Scotland, you stand a very good chance of working it. You don't stand as much chance if you live out in Suffolk. But there you go.
Life's a bitch when you're a DX. Any final questions for Tim? Any more? Well,
Okay.
thank you very, very much, Tim.
You're welcome.
Being very, very brave to come up and talk in my theme. So can we thank Tim in the usual way? Next is lunch, and after lunch at 13:45 we have Olwyn, DOH, talking about noise pollution. So all welcome for that.